Hello all and welcome back. So in this video, let's move forward and now let's try to implement our queue using linked list. Now in the last video, we discussed in depth that what are all the operations and how they can be done in a linked list for my queue. I hope that you have given this a try. In this video, again starting from scratch, we are going to implement each and every of these operations. Okay. So great everyone, let us now go to VS Code. So this is my file. The very first thing again which I have to create is the node, because that's the fundamental unit of my linked list through which we are going to implement our queue. Great. So first thing is self.data. It's going to be equal to data, whatever we pass. We can take value here because I think that is what we have been taking it. And next is self.next, which is none by default. Okay. So this is just a node class which we will be using going forward. Now I can create a class queue using linked list. Great. Yeah, cool. So the very first is going to be the constructor, everyone. We have to make a constructor, which will just take a self. Now let's see what are the different uh, instance variable which we discussed for our queue. One was head, then was length, and then was tail. Okay, maybe what I can do. 1 second. Yeah. So I can just have them in this way. So these are the three variable which I should have, everyone, right? So let us define them. Initially, when the queue is empty, head is going to be none, tail is going to be none. This is very much in line with what we have done. And we are also taking a length 0. Okay. So these are the three variables which we have to make sure, three properties of my queue which we are taking to just implement our queue using linked list. Okay. Great. So let us first see the function. Very first function which we can write, which will be used everywhere, is size. So in size, again, I will be getting the self. Great. I can just actually return self dot length. Yeah. So I can just return this. This is what my size is, right, everyone? Easiest overall method to implement. Next on the same line can be is empty. Return self dot length 0. If the overall length is 0, something which we saw here as well, right? Here also we were maintaining this. This is the implementation of your list. Yeah. So here also we were maintaining and just calculating this size. Okay. So if this is 0, and the good part is all the logic for length is here. So I don't need to worry. Let me make it size only so that it is getting used again. Okay. So two operations are done, everyone. Now let us write the operation for NQ. NQ. Okay. I will be getting a self and the data which I have to add in my queue. The very first thing which I have to do, new node. So just like we created this 4 node when I added 4 here, in the memory, I will have to make sure that I'm creating this node, which I will be connecting or starting my linked list with. Great. So new node, it's going to be node of data. 1 second. Yeah. Node of data. Okay, everyone. So we are passing it like this. Value will go into data and we will be able to use that. One thing more which we should do, because we will be adding it here, self dot length plus equals 1. So I have to make sure that I add 1 to my length as well, something which we are using everywhere, right? Great. So now let us check, everyone. If self dot head is none, that implies that as of now my queue is empty, right? So this implies that as of now my queue is empty. If that is the case, then what we used to do, self dot head equals new node, self dot tail equals new node. So I am making my head and tail both point to the same single node. Let me draw this once again, everyone, so that you understand this. Initially, when I'm saying that my head and my tail both are none, okay, and you have a queue which is, sorry, you have a node which someone is asking you to add. This is only my head and this is only my tail, right? Tomorrow, when you will be adding some new node altogether, then is where I will be changing my tail. Okay. So let us see that as well, everyone. In Q, yeah. So this is the first case. Else self dot tail dot next is going to be equal to my new node, and self dot tail is going to be my new node, right? So how we used to do this, everyone? If you remember, this was my node. Let's say I'm adding another of this node, right? First, I have to make sure that I make this connection. So self dot tail dot next is the new node. And after that, I have to omit this connection and say that, hey, you are the new tail now. And using this particular approach, we were able to see how we were able to actually get a very good accuracy, or sorry, optimization in terms of adding our nodes. So take input function, this all has been discussed in a lot more depth. But yeah, this was the basic idea behind that. Okay. So yeah, I think once this is done, we should be just good to print or rather return f string added data to the queue. Okay. So yeah, I think this works fine. Next, let us do front. Okay, I will be getting the self. For front, again, I will have to first check if self dot is empty. Is my self, is my overall queue empty as of now? Okay. If that's the case, then what I'm gonna do, everyone? I'm gonna print. I'm going to print that, hey, queue is empty. Cannot show front. If this is not the case, then I can just actually return pretty easily. If this is not the case, then I can just return the self dot head dot data. Okay. So again, something which we saw in the last video. When you ask me for this particular queue that, hey, can you tell me the front is kept on my head. So I don't need to worry about anything, right? Rear is on my tail, front is on my head. Okay. So I can just return the data which is present in my head. Cool. So yeah, let us move forward, everyone, if this is clear. Next one is going to be DQ. DQ. So again, you will be getting just the self here. This condition will be surely checked first before we do anything. If self.empty cannot DQ. Okay. So this is how we will be handling this, everyone. And one thing we have missed out, we should return from here, else we will get an error. So after printing, I should return, right? As of now, what I'm doing, I am just printing this and not returning. So this will try to access a none for its data, right? None will be the head and I will be trying to access it. So let me return from here as well. Good. Now, if I have to DQ, the very first thing which we should do is length minus 1. So I'm just making sure that I'm subtract the length, right? Now let us see for the DQ operation, everyone, what used to happen when we DQ. We have to first make sure that we have this data because we will be returning this as well. Let's talk about in terms of 2. If I will be removing this 2, if I will be DQing this 2, then I have to make sure that I first save this data and then I move my next to the next in line in linked list, right? So this is also pretty easy in terms of implementation, something because we have discussed linked list in a lot depth. So what I have to do, data to be returned is going to be self dot head dot data, right? This is the data which I have to return, everyone. Pretty straightforward. And self dot head is going to be equal to self dot head dot next. Great. So I hope this is clear to each and every one of you. Now just one check here to make sure that we don't make a mistake. Okay, let me just explain that to you. Again, it is very important. Let us understand it here. Add a new page. Yeah. So let us just try to understand it here, everyone. Okay, pay attention. If assume that if I just have a single element in my queue. So let's say I have just 10 here. and I have 10 here, right? This is none. I know that my head and my tail both are pointing here, right? So both are pointing here. Second. So this is one mistake again, which many students do in the implementation. Now, when you ask me to DQ on DQ, head will be equal to head dot next, which implies that it will be equal to none, right? So my head, this will actually become equal to, one second, maybe I can just write it here only. It will become equal to none. Okay, that works fine. But don't you think that my tail, which is still pointing here, we should handle this as well? Because, like, normally, let's say if someone is even implementing or wants to add in your overall approach, someone wants to tomorrow add the rear function. Now my queue is empty. Once you dequeue, my queue becomes empty. But my head, I have made none. So I have deleted this connection. But my tail is still saying that, hey, I have 10 with me. And I think that's a problem, right? If that is there, then I think that's a very big problem. If someone now tomorrow wants to access, or let's say someone normally say that he wants the rear of my queue normally, we are not implementing that, though you can easily add that, because if you remember, I said that the overall rear data, this rear data will be present in my tail. You will give the output as 10, which I believe is wrong. Why have you done that? Because you have not reset your tail. Okay, so I hope each and every one of you are able to understand this. In a single element, we will have this problem. In a single element, we will have this problem where if you have not reset your tail, we will have to, we might make an error. So, for the overall benefit, to make sure that we don't give this kind of output, we should also make this as well. Okay, so I hope each and every one of you are able to understand and catch this mistake. Many of you, if you tried, might have missed out on this, and that is completely fine. But yes, it is very easy, important to handle this, because tomorrow, if someone is, let's say, implementing your class, or if someone is inheriting your class and he wants to, let's say, add the rear get rear kind of a method just along with this front, that is going to make an error. Okay, and normally also we should always make sure that our internal implementation is always right. If I leave my tail there, then it is wrong. As of now, again, my head and tail both are none, because my queue has become empty. Thus, if it is none, then self.tail should also be none. Okay, great. So once we have done this, we just have to return data to be returned. Okay, everyone. So always remember that you handle these cases where you have a zero node, you have a single node, any of this kind of a thing is there. You have to make sure that you always understand how is that going to just change your overall implementation, because that is where majorly the edge cases happen. So cool, everyone. Let me now help you to quickly revise what we have done. We have created a node class. In the node class, of course, we will just be having the data and the next, the most fundamental unit of my linked list. We are using queue, but implementing that using linked list. We have initialized it. We saw in the last video how head and tail both are required, and why I will be needing length as well. Because having length gives me the freedom that I can actually I don't have to go and see whole of my linked list to get the length. So it is able to help me in efficiently getting out the size. Size, directly the length, is empty, checking if size is 0. NQ, adding a new node. Very much similar to the way we used to do in our take input function, the optimized one. If I don't maintain a tail, then all of you can imagine that we will be doing an ON square approach, like of adding, right? ON, it's fine. And I think one more thing, everyone. So I have added O1 here, because in queue we will be adding things one by one, right? It is not some take input function of my linked list where we are given, let's say you have to add 10 elements in one go. Okay. So again, you will see that these are just some operations I'm doing. Okay. So it's all happening. All of this is happening in a single some k constant work, which is O of 1. Great. Front. If queue is empty, cannot show front, else we can just return the data. DQ, length, data to be returned, and let me write this as well. Very, very important to handle the right form of queue. Because if you are saying that your queue is empty and your tail is not pointing right, then it's a problem. Self.date also none, and we can just return the data to be returned. We have already handled this self length. Okay, so cool everyone. Let us just copy this whole. The understanding is that because it's an abstract, I don't care how it is implemented, just as long as all my operations are fine. So I'm using queue using linked list now. I think all the functions are the same name. We don't see any error here. And yeah, let us try to run this everyone. First, let us draw it ourselves. So it's going to be something like this. You are adding 10, then you are adding 20, and then you are adding 30, right? Wait, so size will be 3, is empty will be false. Front will be 10 because 10 was the first one to be added. This is my head, and this is my tail, everyone, right? Great. When I DQ, I will be moving my head forward. So I should get 10 here. Again, when I DQ, moving my head forward. Again, should get 20 here. Front this time will be 30 and size will be 1. So this should be my overall output, I guess, everyone. Let us try to run this quickly and see if it is working in a similar way. Okay, some error. What is it? Queue using object has no attribute DQ. One second, I think we have made a spelling mistake. DQ. Okay, my bad, yeah. Spelling mistake is there. Okay, I think we have made a spelling mistake on that. So let me correct this. This is the right spelling, right? DQ. Great. Cool. So yeah, just let me save this as well. Let us run this. This was the output. Yeah. Cool. So yeah, we are able to see that it is 3 false, 10, 10, 20, 30, and 1. So seems like everything is working as we would expect. We are able to see the right answer. And our queue, just implemented using linked list, works as well. Okay. Great. So let me just help you this visualization of once more, everyone. So this is a website which I found. Now you will find that this is an empty, this is queue linked list implementation. As of now, initially, as we took head and tail, both are none. Let's say when I enqueue 10, okay, and I will just reduce the animation speed. So you can see how it is in line with what we have discussed. Okay. So yeah, great. Let us enqueue, see what's going to happen. A node it gets a value, and then because your head was none, head gets attached to this node, and tail is also now pointing to this node. Let us now take 20. Let us take 20, everyone. See, a node gets created. This is implemented, I think, using head pointer. So it is not a efficient implementation. Let us see for 30 what it's going to do. So let me make a animation slow. Okay, so that we all can catch how exactly is it adding the node. Right now we saw, like it was a little fast, but we saw that how it is starting from my head. So let us enqueue everyone, and you can see that it is none. Okay, this one is none. So similar kind of a convention which we followed. Let us enqueue. See, a 30 gets created. It is getting added. And directly, yeah. So right this time, of course, because that was the first node, it is using this tail node to add. Let me add 40. See, a node gets created. Tail will point to this first, and then tail will change its pointer. Okay, so I hope all of you were able to see. Let me add 50 as well. See what is happening. First, a node gets created, then tail will point to this, and then this will happen. So this overall last tail first point to this, and then tail changes to this new node. Okay, let us DQ now, and you will see how just head changes back. See, 10 gets returned and head changes to this. And the last node now is lost. Similarly, if I DQ once again, 20 gets returned and my head moves a step forward. Again DQing, 30 and 40 is here. DQing it again, 40 gets back and it's moved forward. And pay attention now, everyone. When I will DQ this last element, you will see that how both of them is going to become none. Okay, so see, 50 gets returned and both are none now. The implementation in the backend is right, because else tail would have still be pointing here. Okay, So I hope all of you are able to understand. It is showing the DQ value also, like the value which was popped, which was returned. And I'm pretty sure that through this, you will be able to understand properly. Let me add this, and thanks a lot for this website. You can just visualize. Okay, because I want that each and everyone who is even doing this queue for the first time, he has a complete in-depth knowledge and comfortability. So visualization for the process. Great. So yeah, I hope that with this visualization, with the way we have implemented, and of course with an awesome discussion which we had here, all the operations of how we do or how we implement queue using linked list is clear. Now, what I will suggest everyone is to make sure that you try to just implement this at your end once without seeing the code. You can use this actually, that is not a problem. Okay, you can still use this overall visualization, that is not going to give any issue. Though I will suggest ki based on our discussion, just see the last video and try to implement the same from scratch. Okay, once you do that, you will be a lot more comfortable. And if someone tomorrow asks you the question to implement any data structure, you will be more than happy to do that. Okay. Cool on. Then let's meet in the next video where we will learn now about the type of queues. Thank you.